In recognition of Space Exploration Day, which is celebrated on July 20th, in commemoration of Neil Armstrong and Buzz Aldrin landing on the moon on July 20th, 1969, and actually conducting the first moonwalk late night July 20th and the early morning of July 21, we're going to take a look at space travel, which is now opening up beyond that travel just by astronauts and scientists. So the opportunity and the potential of civilian space tourists. Now, there were a few space tourists from 2001 to 2009 on existing missions, but starting in 2021, we're seeing more and more space tourists traveling on rockets by SpaceX or Blue Origin or Virgin Galactic. Traveling in space, whether you're talking about an astronaut, a scientist, or one of these civilian space tourists, is often associated with an emotional epiphany. And now Frank White, in his 1987 book, The Overview Effects Space Exploration and Human Evolution, describes this as an experience where you are basically looking at the Earth as a tiny, really fragile ball of life, which is hanging in a void. It's surrounded by a paper-thin atmosphere, and looking at the Earth from outer space, there are no visible national boundaries. And so in many ways, like what our students do when they travel abroad to other countries to experience different cultures and different perspectives and to learn from different peoples, we learn about our place within society, our place within the planet, our place within the universe. And we see how fragile life really is and the need to protect it. Despite the thrills and the emotional experience of space travel for an astronaut or a civilian space tourist, there are serious environmental concerns associated with the rocket launches. It's from this perspective that this week's Ethical Dilemma in Science is going to take a look at, is the thrill of space tourism worth the environmental impact? Up until this point, the environmental impact of rocket launches and space travel has been fairly negligible, and that's mainly because there haven't been that many launches. On estimates, the amount of rocket fuel burned is less than 1% of the amount of fuel that is burned for airplane travel throughout a year. Now, a Virgin Galactic rocket flight emits about 4.5 tons of carbon emissions, which is twice the Paris Agreement's recommended annual individual carbon budget. And so we're seeing the greater opportunities for increased pollution with increased rocket launches and space travel. And because of this increase that is expected, scientists are not sure about the effect on the upper atmosphere. In this 2022 article in Earth's Future, it shows the number of launches that occurred in 2019. And so we've got in the center of this diagram, we've got a map of the Earth. The orange circles represent launches, with the bigger circles representing bigger launches. And we see that these launches are going to be associated with a variety of different fuels. The darker purple is associated with solid rocket engines. We're basically using metallic compounds that emit aluminum oxide particles and hydrochloric acid into the atmosphere that could be potentially damaging it. The darker blue is kerosene, so an example of a fossil fuel, carbon-based fuel that is burned, that again, like burning of hydrocarbons in our cars, we're contributing to the production of carbon dioxide. We've got hydrogen in this lighter blue, kind of showing up here and here. This is actually a cleaner form of energy. It's using liquid hydrogen and liquid oxygen, so it has much less pollution because it's going to be emitting water and minor combustion products. And so that's the type of engine that we're seeing on the Blue Origin's BE-3 engine. And then the remaining, this kind of really light, kind of grayish blue, these hypergolic rocket fuels are going to be a combination of chemicals, toxic liquids in most cases, that react violently with one another. But they're not as powerful a form of rocket fuel, and because of that, they require a much greater fuel capacity, and that's an older form that's being phased out. So, the main concern associated with rocket launches and space travel is what is happening within the atmosphere. And so, if we take a look at the atmosphere, the troposphere is the area of the atmosphere that's closest to the ground. It's basically where we are living, and it's where sadly, our pollution and the effects of human activity are accumulating within the environment. Above that, so going about 6.2 miles or 10 kilometers above the surface, we're going to get to the stratosphere up here. And then beyond that, going beyond about 50 kilometers, we're going to get to the mesosphere. And so we're looking at areas of the atmosphere that pretty much up until this time have not had much human impact. But what happens when we start traveling through this area and potentially polluting it more? This diagram, again, illustrates the different layers within the atmosphere. So down here at the bottom, we've got the troposphere, roughly about 6 miles, about 10 kilometers up from the surface of the ground. And this is where we have airplanes flying. We're down here on the surface. And this is where we basically have most of our impact on the environment. However, when we do a rocket launch and space travel, we're going to move from the ground onto the Earth out into space, and we're going to pass through the stratosphere and pass through the mesosphere. Now, in the process of doing that, if we are burning these hydrocarbon fuels, we're going to be generating a black carbon soot from these rockets. And about 2/3 of the propellant is going to be released into the stratosphere and the mesosphere, the upper levels within the atmosphere. And this black carbon soot in the upper atmosphere is estimated to be about 500 times worse than the equivalent carbon and carbon dioxide in the lower levels of atmosphere. And so we could be potentially disrupting what's going on out here with the upper atmosphere. This dark carbon is going to collect ultraviolet light that's going to heat up the stratosphere. And it's also thought that some of the chemicals that are released in the rocket launches, in many cases nitrogen oxides, are going to be a form of air pollution that could potentially disrupt the ozone barrier. And so the ozone layer is protecting us from the harmful UV radiation. And so we could end up with kind of holes in the atmosphere as well as heating of the atmosphere with increases in rocket travel. So you might be asking the question, why does it matter if the atmosphere is warming up a little bit? And so what we've got here is a diagram. And so basically the North Pole would be kind of behind my head here. The equator is down here on the far right-hand side. Basically what we're going to be seeing is global wind patterns. We're going to be looking at circulating air. And so using the basic idea that hot air rises and cold air falls, we see the situation that hot air is going to be basically heated up within the regions around the equator. It's going to rise up, and then further away from the equator, the air is going to cool down, and so it's going to drop down. And so we get this little pocket of air current that is going to be circulating here. There's going to be another cell of circulating air kind of like this, and then finally a polar cell over here. And what happens with this polar cell is that this basically keeps these other cells kind of in place. And so this polar cell, using this cold air, is really not going to mix with the air that's coming from the equator. It is going to be circulating kind of on its own and contributing to global wind patterns, especially when we make this further complicated by adding in the rotation of the Earth. Now, potentially heating the climate and heating these polar regions could alter the jet stream as well as change winter patterns. And so if we take a look at this, on this diagram, we're basically taking a look at the Earth here. We've got the equator down through in the middle, and we're going to see those kind of circulating pockets of air that are going to be going on. Now, normally, we've got that cold air that's going to be staying up towards the North Pole or the South Pole region, depending on how we're looking at it. And we've got this little oscillation of the jet stream kind of going back and forth. However, if we've got warming of the atmosphere, warming of this polar region, we've got less of a temperature difference between the polar regions and those intermediate latitudes. And so because of that, the polar air is going to be coming down to much lower latitudes. So we can see, polar vortexes, polar winds that are coming down into the United States. This past winter, we saw a lot of polar winds flowing into England and Europe, as well as the warmer air kind of going up higher. And so we end up with very severe changes in the winter storm patterns, as well as affecting the average rainfall in that area, which could dramatically impact on the environment and the ecosystems, the plants and animals that are able to live within that area. To illustrate the potential effect that we're looking at with space tourism and an increase in rocket launches, this is a 2020 market analysis by NSR taking a look at space tourism market revenue. And so we've got years kind of down here along the x-axis and millions of dollars up here. And so kind of at the 2028, where we're taking a look at it, kind of peeking out at here, we're looking at a revenue of about $3.5 billion, representing a lot of space flights. And it's estimated that this space tourism could be generating upwards of hundreds of recreational flights per year with relatively few passengers on each flight. And so again, we're looking at the fact that these civilian space tourists on a single space launch, a single rocket launch, are basically burning 50 to 100 times the carbon that passenger would be doing on a long-haul airline flight. And if we increase that by having many, many, many more launches per year, we're going to see a greater impact of these rocket launches on the environment. With this background information, we now get to this week's ethical dilemma in science. Is the thrill of space tourism worth the environmental impact? And in order to answer that question, we've got some prompts or some sub-questions to consider. Should the environmental impact of space tourism be mitigated in some way? If so, what possible types of mitigation should be considered or implemented? If a mitigation strategy is implemented, should the mitigation be recommended or should it be required? And then finally, if required, how should the mitigation be monitored and enforced? Thank you for listening to this week's Ethical Dilemma in Science. Please see the description below for additional information and references. Thank you and have a great week.